And now we're going to switch over and we're going to have Dr. Maria Silveira come speak to us. She's a little background on her. She also comes to us from Brazil, and her degree, she got her degree in agronomy and her master's and her PhD in soil science and plant nutrition. So she's multitasking. So she performed her postdoc work research with the University of California, University of Florida, and Texas A&M University before coming to the ONA Research Center in 2006. Here at ONA, she addresses critical soil nutrient management and water quality issues that affect the forage and cattle industry in Florida. And so I think we're ready.
Thank you all so much, those who are here and those via Zoom. I'm going to lower this a little bit. And don't worry, if you watch the webinars, if you read my articles on the catamines, I'm not going to be talking too much about my biosolids research, even though the title says biosolids research. What I decided to do here, and here's a brief outline of my presentation. Since the state regulations chapter 62, 60, 40 recently changed, those changes were implemented June 21st this year. I'm going to spend a little bit more time talking about those changes. Leandro Vieira, my PhD student, mentioned very quickly what those changes are, but I'm going to get into a little bit more detail because the cattle industry has been, I would say, pioneer in terms of research, supporting biosolids research. Biosolids being the cattlemen's research priority for a number of years, and they've been supporting research. I'm going to show demonstration site that was established in 2014. So a lot of those agencies, we knew that the problem might exist, but the cattle industry were the first one to invest money in conducting this type of research. And also, I want to acknowledge the students who participate in this research. Recruiting a student sometimes can be difficult, and telling the student they're going to work with biosolids, it increases the level of difficulty even more. So it takes a special type of person to do this research, but they understand the importance and how that can impact not only the cattle industry, but also the society in general, because this is a byproduct from urban settings. So without further ado, and I'm not gonna spend too much time talking about the benefits because a lot of producers understand what the benefits are. Not only biosolids are excellent source of nutrients, with the exception of potassium, that usually is fairly low in biosolids. Biosolids provide a lot of macronutrients and micronutrients. Because of the organic matter, it also improves soil physical, biological, and chemical properties. That's particularly important for our soils. For those who live in Florida or being in Florida long enough, you understand how poor our soils are. So adding a little bit of organic matter can have tremendous impact on the soil, and if you are a producer, on forage production, retains more water. It's also being biosolids being extensively used in reclamation, mining lands, or any type of disturbed lands. And also from the environmental perspective, a lot of focus is being placed on biosolids relative to the ability to sequester carbon and reduce greenhouse gas emissions. I'm not going to talk about this today, but if you compare the carbon footprint of biosolids versus commercial fertilizer, there's a tremendous advantage of using biosolids. It has a much lower carbon footprint. So there are a number of risks, of course, as many things in research or even in life. Too much of a good thing can be a bad thing. So if it's misused, mismanaged, it can cause a number of issues, including nutrients, pathogens. One of the most common source of complaints in sites receiving biosolids is odor. Even though there's no direct impact on human health, or odor doesn't cause any, doesn't have any human health impact, but it's a nuisance. So a lot of neighbors are not happy, especially if you are applying biosolids close to the holidays. There's a number of also emerging contaminants of emerging concerns that have been, some states have very strict rules in terms of organic contaminants. You may heard PFAS. It's that's a buzzword. All states are talking about PFAS. And there's a lot of work that's being done to address those emergent contaminants. Like I said, it's only a 15-minute presentation. What I want to refer you to a couple of publications. So if you are concerned about risks associated with biosolids, there's a number of extensive literature reviews on this topic, and you can learn a little bit more. I'm going to mention 3 references here. These 2 published by the National Academy Review. One was in 1996 and one was in 2002. How do I get my mouse here? This one? Yes, laser point. I cannot read without my, okay, yeah. So this report was published in 1996 and they published an update report. Basically, the bottom line is we have to work with science. So there's a lot of emotions associated with biosolid, the yuck factor, because it comes from human. Yes, it comes from human, but it goes through treatment process before it can be land applied. So this report, it's focused on science, and basically the conclusion is that part 503, which I'm going to explain very briefly what it is, it's basically the federal regulation that governs land application of biosolids. There is no scientific evidence that biosolids being linked to human health. There's no evidence that biosolids exposure cause any adverse effect on human health, and there's different pathways for that exposure to occur, even in a more severe case where humans, an individual consumes the biosolids. There's been some risk assessment studies evaluating the potential risk. So basically, there's no scientific documented outbreak of any disease caused by biosolids. More recently, Dr. Sellers mentioned that I recently have the honor to be the chair of this multi-state group. It consisted of probably 60 individuals right now from from 33 states. And they have 45 years of biosolids research. So they, some of you may heard about this report that Office of Inspector General from EPA published about some concerns related to biosolids. And this group that I'm referring here, the W4170, wrote a report responding to this EPA report. So the link, I'm not gonna get into details about the report, but the link is here. If you're watching on Zoom, didn't have a chance to get that link, which can be, I don't think anybody will have a chance, email me and I'll be happy to share the report. It's in if you Google W4170, it's also in the website of this multi-state. But it provides the scientific evidence where the flaws in that report was. So, and now I'm going to switch over the regulations. What have changed in terms of regulations in Florida? Before I talk about the regulations, and I have to describe what the different classes of biosolids. So everything that I'm going to be referring during my presentation is applicable to Class B. So most of the biosolids that are land apply mainly to pastures. In the past, citrus was also important cropping receiving biosolids, but now it's mainly applied to pastures. So we are always referring to this Class B material. And those are the changes in the regulation that occur, refers to this Class B. There's also Class A or double A. So those are the materials that undergo further treatment before it can be a land applied. And oftentimes they are labeled and marketed as commercial fertilizers. So they are under different regulations. They're FDEX control the use and distribution of Class A or double A in Florida. So in terms of Class B in Florida, we have to, in order to land apply material, some folks have this perception that you can just pick a site and dump. So it's not landfill. It's a very strict regulation that goes from, you have to meet this federal regulation, you have to meet state regulations, and about 1/3 of Florida counties have also local ordinances. So today I'm going to talk about those changes in the state, the Chapter 26040 that was recently implemented. In order for me to talk about those changes, I have to provide you a brief outline when those things occur. So in June 2018, I had a chance to participate in this regional biosolid symposium that was held in Martin County. I was one of the speakers, and that was the beginning of this process. That's when Florida DEP announced the creation of a technical advisory committee that was tasked to evaluate the current biosolids management practices and provide some inputs for DEP, how they could improve land application of biosolids in the state. So right after this meeting, the committee got together fairly quick, and they held 4 meetings, public meetings from September 2018 to January 2019, I had a chance to participate in those all 4 meetings, and I share some of my scientific results in 2 of those meetings. And different entities and the general public also had an opportunity to voice their concerns. So it was a very interesting process. So in January, end of January 2019, that committee, the TAC, the Technical Advisory Committee, was disbanded, and DEP began the rulemaking process. In June, DEP also hosted three public workshops explaining what those changes were, and fast forwarding 2 years after those workshops. So there was a lot of things that happened between 2019, but finally the proposed amendments to the state regulations became effective this year, June 21st, 2021. And those changes that I'm gonna go over quickly are mainly focused on phosphorus. Let me see how I'm doing with my time. Good. So very quickly, Leandro mentioned that now new sites, if you are currently applying biosolids, you probably, and you may not be aware, now application is prohibited in sites with seasonal high water table less than 6 inches. So the soils that can get flooded for a significant period of time will not be eligible for land application. And the sites also must be enrolled in the MP program. Application rates have drastically changed. So we, in the rules and the nutrient management plan, which became much more stringent, you are required to determine this soil P storage capacity, phosphorus storage capacity. So it's not the traditional soil fertility test anymore. So basically, this soil P storage capacity tells us how much additional phosphorus that soil can retain before it becomes an environmental problem. It also requires the determination of water extractable P in the biosolids. So not all biosolids are the same. Some have higher concentrations of soluble P. So more soluble P, greater likelihood that phosphorus can be leached from the receiving site. And those application rates can be adjusted based on the soil P storage capacity and the percentage of water extractable P in the biosolids. I'm going to show a table before I talk about the water quality. So the new regulation also includes this table, and you see it's just for pastures, because pastures, as I said in the beginning of my presentation, are the main cropping receiving biosolids. So these are the application rates that producers will be allowed to use when they are using biosolids. It's either limited by nitrogen or phosphorus. Most likely, the majority of the cases, phosphorus will be the limitation. So in other words, biosolids will have to be applied at a P-based rate. And you look at this table, they're fairly low P application rates, many times almost impractical. How can you apply such low rates? And what that also means is that if you are using biosolids, you're probably gonna have to supplement your fertilization program with inorganic fertilizer, because you're not gonna supply sufficient amount of nitrogen. And also there's water monitoring requirements. So it becomes more difficult from the producer standpoint, and there's more frequent inspections. I think this is one of the things that will probably limit severely land application, especially to pastures. When you look at this is verbatim from the 62/60/40. So at any time that you are applying more than 160 pounds of nitrogen per acre per year, or 40 pounds of P2O5, 40 pounds of P2O5 is equivalent to 17 kilos of P, 17 pounds of P per acre. That's a fairly low P application rate. So that means that pretty much all sites will have to have water quality requirements. So what's gonna happen? I think this is my perception, a lot of materials will either go to landfill, which is not an environmentally friendly option of disposal. Some might be converted to class AA. So municipalities will have to invest money on converting this class B into class AA, or the haulers will have to drive further to other places to dispose. We have 21 million, I think the population in Florida is about 21 million, and we are the folks who generate this residue. With 1,000 people moving to Florida, the biosolids issue problem is not gonna go away anytime soon. So what are we trying to do? Biosolids is one part of my research program, and very briefly, I'm going to mention what we're doing in terms of addressing these regulations. Very briefly, again, I'm not going to have time to go into details about, but I believe that the research needs to be available to the public. So all this information that I'll be sharing with you today is being published in top tier journals in soil science. And most of the first authors here are students who were involved in these efforts. So one study that I want to mention, I mentioned this water extractable P in the biosolids. Not all biosolids were the same. How much do they differ? So we use this approach that's called rainfall simulation to evaluate the solubility, phosphorus solubility in different materials. And like I said, this paper was published in 2019. What I want to show you very quickly, I'm going to skip I'll be happy to show talk to you about the details of this experimental approach. And as you can see, we use these boxes and we simulate rain, like the name says, a rainfall simulation. But what I want to show you, the data that I'm going to present cannot be directly extrapolated to field conditions. As you can see, these boxes don't mimic what happens in the field, but we want to see the relative comparison between the treatments. And this is the relative comparison that I want to show to you. This large yellow bar is commercial fertilizer. Again, this is a worst case scenario. The soils were wet, and we imposed this extreme rainfall event on the soil just to see how much phosphorus was going to be lost. No plant interaction. And what I'm showing this graphic here is runoff. It's flow weighted runoff over the course of these multiple rainfall events. The yellow bar, as I said, is fertilizer. The first bar here, the tiny bar here in the blue, is control. That means just soil with no amendment. And all the other bars are different types of biosolids. There was a criteria we used to select these materials because they were our main focus was on the St. John's water river basin, because there's a lot of biosolids that are now being applied in that region, and that there's water quality concerns, and folks were concerned whether that was caused by biosolids. So we selected materials that were mainly used in that region of the state. You see the same letters means that the averages are the same. So with the exception of this blue bar here, all the biosolids result in similar runoff concentration as our control soils. This material here is fairly unique. It's from a treatment process that's called a biological P removal that usually produces biosolids with high soluble P. And what I want to show you, I'm sorry for the very busy table, but if you look at this last table, is the percentage of phosphorus that we added that were lost via runoff or leaching. Usually for biosolids, this number was between 1% and 5%, with the exception of the Orlando material. And you can see the circle here is the inorganic fertilizer. So the bottom line of the study is, if you're going to fertilize your crop or your pasture with a P source, biosolids are a much more friendly, environmental friendly source, because they're less soluble and therefore resulting less phosphorus losses. Like I said, boxes are not realistic of things that process that happen in the field. So we established this study. Well, the demonstration site was established in 2014. But the study was, we instrumented these plots in 2016. And like I said, I want to acknowledge the beef cattle enhancement funds for providing the funds. This is a very expensive study because, like I said, those plots have been heavily instrumented. We can monitor movement of water and nutrients in the soil profile. Yeah, I'm not going to spend too much time. What I want to show you is this data is leachate P, soluble reactive P, so the very soluble forms of phosphorus in the water that leached over the period of 2 years. So this is 2016 to 2018. We continue this data. What I'm focusing is the data that's been published. Again, we're comparing control with biosolids and inorganic fertilizer. The open squares here are inorganic fertilizer. You see these peaks over time, and you see this blue arrows. Those are the times when we apply fertilizer in the field. And you can see the peaks usually occur for inorganic fertilizer right after fertilization. So over the course of 5 years that we are monitoring leachate P, there was no difference between biosolids treated plots and control plots. I'm not going to spend too much time in this table. This is, again, a mass balance. We need to account. We apply X amount of X pounds of phosphorus in it. We have to find out where the phosphorus is going. It's either plant uptake, it's accumulating in the soil, or it's leaching. There's no other pathway for phosphorus. Phosphorus doesn't disappear. So in terms of water, how much of the added P they end up in the water, it's about 0.1% or 0.2%. Even though you saw those spikes in the inorganic fertilizer, but the proportion of phosphorus that was lost was significantly low. The reason for that is because plants, in this case, bahia grass, is very efficient at bringing that phosphorus. Phosphorus will only be susceptible to losses if the plants cannot utilize. So the conclusion was that, yeah, repeated application of materials, and we're following the proper recommendations, cause no impact on nitrogen and phosphorus leaching. Biosolids pose a much lower risk than inorganic fertilizer. And more importantly, this last bullet point is nutrient management in soils can be, in biosolids amended soils, can be done even in soils with high water tables, which was the case of the soil that I showed the data. Feel free to email me if you would like a copy of those publications or any additional information I'll be happy to provide with you. Thank you.